Good morning, everyone. Today I'm going to talk about chapter one, which is the easiest topic. But even though this seems like a very easy, but as I said earlier, make sure you understand every single concept. Okay? If you're not sure about it, don't just move it. Okay? Good. And then first chapter is very simple. It's about the motion, and then motion is, just moving object, right? Because for this chapter so far, we assume the object is moving in one-dimensional space, so either to the right or to the left, okay? And then, whenever you see this lecture note, you will see sometimes this type of quick check questions, okay? Whenever you see this, pause the video and then think about the answer and then try to solve it, okay? And I will give you the time to pause it and think about the question. So motion diagrams are shows of two cars, right? Here, and red car is moving to the right, and the yellow car is moving to the left, and then both have the same time interval here, right? That means you take a photo in a for car A in a 4 photos for 4 seconds, right? And the second yellow one, you take a 3 photos during 2 seconds, right? So the question is which car is going slower? And then pause the video, think about it, and then let's move on to the next slide. The answer, of course, is a car A, right? Why? Because you have a 4 snapshots, which means if you come back here, right? So the car A and the car B, moved the same distance, right? But the car A has a 4 snapshots. That means it take a 1, 2, 3 seconds, right? While yellow car take a 2 seconds, right? So the car A is a slower. It's a very simple question. And modeling, we have a particle model. Even though they said the car is moving and the box is moving, right? But you can assume, instead of drawing whole car, you can just have a dot, right? Which is a particle here, as you can see in the picture B, right? So then you see sometimes you have a black dot here, right? So that means that this is the location of the car. And then you have a number here. This is the frames, or sometimes it can be a time, right? So the particle model of a motion is a simplification, in which we treat a moving object like our car as if all of its mass were concentrated at a single point. Okay. And next, again, you have a quick check, pause the video, and then think about the answer. Okay, and then your exam, which will be mostly multiple choice question. The format is very similar with these questions. Okay, so two runs jog along a track. The positions are shown at 1 second intervals, which is very similar with the previous question. Which runner is moving faster? Pause the video, think about it, and now move on. The answer, of course, is again A. Why? Because you have a 1 second interval, right? So in 1 second, particle A moves this distance, and the particle B moves this much, right? So the A travels longer, so that means A is faster, right? And then another question, two runners again, you know, the time, this time at each position are shown, right? And which runner is moving faster? Pause, think, and the answer is they are the same, right? Because you have a number here, 2 seconds, 2 seconds. They travel the same distance, right? Their speed are the same. It's very simple, right? So far so good, right? So then now this is our first concept. Position, what is a position, right? So in order to describe or specify position, we need a reference point, which is the origin, right? You already have an idea. And then, because this is one-dimensional space, we need a direction, right? From the origin. That means the direction here is what? Either to the right or left, right? And then origin for this case is here, right? The car is at position 4 plus 4 miles. So that's a location. And the cow minus 5. No, it's so easy, right? And then coordinate, it's a symbol, so you already know that. And then this is a very important first concept of this course, which is a displacement. Displacement is a change of position. So normally whenever you see, change of something in physics, we will use this delta symbol. So this delta symbol always means a change. And then whenever we see the change or differences between two quantities of physical quantity, it's always a something final minus something initial. This is the definition of a change of something delta. Okay? So always a final minus initial. Okay? So the displacement, very important concept. Displacement is the change or differences between the final position and the initial position. So for example, you have a Sam's displacement. Initially here, finally here. So that means final location is a 150 minus the initial location 50. So the displacement is a 100. What if, Sam was initially here and then finally here? Then what is the displacement? It's a initial is a 150. Final is a now 50. So final 50 minus initial 150. So then displacement is a minus 100. Right? So to make sure displacement, you will learn it later, is a vector. So whenever you see we talk about displacement, you always describe it's a direction. In one-dimensional space, it's a direction is a sign. So make sure you always have a sign minus or plus. Okay, and then what is the physical meaning of displacement? If displacement sign is a positive, that means the object is moving to the right. Okay. If the displacement sign is a negative, that means the object is moving to the left. Good? Any? Again, whenever you have a question, please let me know, email me. I also plan to have a, live Zoom sections, probably 10 minutes or 20 minutes every week, depends on, your availability. So, but I will let you know soon, okay? But not this week, probably from the next week. And you have a very simple example. And then Emily is enjoying a bicycle ride and then runs east to west past a water tower, right? Define a coordinate system so that increasing x means moving to the east, right? At noon, Emily is 3 miles east of the water tower. Half hour later, she is 2 mile west of the water tower. What is her displacement during that half hour? So then, to exchange questions, very simple, right? You have a water tower here, right? And then this is a origin. And then Emily start from here and then ends here, -2, starting 3. So again, displacement is always a x final minus x initial. X final here is what? X final itself is -2. and then you still have a minus sign here, and x initial is a 3. So that means that this is a minus 5, right? So the mathematical answer is important. Again, because the displacement is a vector, you need a sign and magnitude, right? But you have to focus on the physical meaning of displacement. Minus 5 actually means what? Emily moves to the left by minus 5, by 5 mile, right? So that means from here, 1, 2, 3, 4, 5 miles moving to the left end. Okay. This is very interesting. Let's assume your water tower, let's assume this is not your, origin. Let's assume this is your origin, new origin. And then the physical meaning of displacement should be the same, right? Because anyway, Emily start from here, even though you don't have this location, position information anymore, because you have a new origin, right? So basically, then this is a 5. This is gotta be 0, right? Based on the new origin reference system, right? But anyway, physically, Emily start from here, ends here. So that means she anyway moves 5 miles to the left. So then that should be same for new origin as well. So we can check it. New delta x displacement new is what? Final is 0. Initial is a 5. So you see, you still have a minus 5. So the displacement, the physical meaning, still the same. Emily is moving 5 miles to the left. It really doesn't matter, wherever you choose as your reference. Okay, again, two things. Displacement definition, x final minus x initial. Okay, and then this is a displacement, physical meaning of displacement is what? How much unit it moves to the right or to the left. Right? This is the solution. Again, even though I don't have time to go over every single details in the textbook, so make sure you must check and read whole chapters by yourself. My explanation is not perfect and completed, right? So make sure again, textbook is the Bible, okay? So you have to read the whole textbook and make sure understand the contents in the textbook, okay? And then quick check again. Maria has a position 23. Then she undergoes a displacement delta x minus 50. What is her final position? Pause and choose the answer. So the answer is A minus 28. So now it's a little bit difficult, but you now know delta x is minus 50, which is what? Position was a final, displacement is a final minus initial, right? Her final is what? We don't know. Initial was a 23. So then your xf, if you move this one to the left side, right, is what? Minus 50 plus 27 is a minus 27 meter, right? You can also solve it conceptually. This is the initial position of Maria, right? So then displacement, what is the physical meaning of displacement? In the direction to the left, how much? 50, right? So that means displacement minus 50 means the object is moving to the left minus 50 meters. So now your position, initial position is 23. This is origin. So that means displacement says, okay, I'll move minus 50 meters. So you move minus 23. So you have additional minus 27 so that you can have a minus 50, right? So you can either solve using mathematical definition or the physical meaning of it, right? Again, you have a bug here, and then you're looking for distance trouble. Basically, this is a total distance trouble, and then displacement. This question is very important. Pause and think, and choose the answer. So the answer is minus 60 and minus 30. So total distance trouble, initially the end was a 40. And then we moved to where? Here, 15. So how much distance it travel for the first move? 25 centimeter, right? And then it moves from here to here, right? So it moves another 15 centimeter. And now it moves from here to here, which is another 20. So the answer for the distance it travel is 60 centimeter. But displacement, again, very important concept. Displacement is what? Delta x is x final minus x initial. What is x final? 10. X initial, 40. So displacement is minus 30. So then, what can you tell me more about displacement? Displacement does not depend on its path. It only depends on initial and the final position. Let's assume if the ant move, boom, boom, and then back and forth several times, and then come back here again, your total distance travel will be changed because it moves back and forth here more, right? But the displacement still the same. Why? As long as your initial and the final positions are the same. So now let's assume you have a track, soccer field, football field, right? So then you have a 100-meter run. This is 100 meter. So you're running from here to here. And then if you run back and forth and then come back here, what is your total distance travel? Of course, it's 200 meters. But what is your displacement? 0. Why? Because your initial position is here and your final position is here. Right? Because again, displacement only depends on initial and the final position. It does not depend on path. And the next concept is the velocity, and actually velocity and speed. Now, the definition. So let's talk about this slide first. Motion at a constant speed in a straight line is called uniform motion. Constant speed in a straight line, uniform motion. So this car, for the first second, this car moves 40 feet. And then another second, this car moves another 40 feet. Another second, another 40 feet. So the car moves at a constant speed, in other words, uniform motion. Bicycle, 1 second, 20, another second, 20, another second, 20. So it's a constant motion. So it's a uniform motion. So the definition of speed. So now remind yourself what we just talked about. We talked about two parts. Total distance travel, right? Versus what? Displacement. So the speed, the definition of speed is what? Time and distance travel, right? So this is always your distance travel is always what? Positive number. So your speed is always a positive. But now, what is your velocity? Sorry about that. Your velocity is a time and displacement. Again, your displacement is a vector, so it can be either plus or minus. So that means your velocity can be plus or minus. I will talk more about details in the next section when I explain velocity, but you better to see the differences at this point. So now you have an example problem. Jane worked to the right at a constant rate, moving 3 meters in 3 seconds, right? Draw her motion diagram. So that means 3 meters in 3 seconds, right? And a constant rate, right? So that means every second she moves 1 meter, right? So when t equals 0, she passes a x1. So you have an origin here. So this is origin, this is a 1, right? So she was here when t equals 0, right? So then, where she was? When t equal minus 1. So she was here when t equal minus 1. And then you have a t2, t1, her position is 2. t2, her position is 3. And then her position is 4 when t equal 3. And then one more, 5, 4. Right? You can also have to pause it and then you can solve it, right? And then velocity and speed, speed measures how fast an object moves. But velocity tells us both the object's speed, which is the magnitude, and its direction, as I said, right? Velocity, definition, displacement over time, right? So again, let me give you one quick question. Again, you have a 400-meter track, and you start from here, starting. And then you run 100 meter in 10 seconds. And then you come back another 10 seconds. So what is your speed here? The speed is what? Distance traveled over time, right? So you have a distance travel 200 meters because you move back and forth. And then how long did it take? 20 seconds, right? So then what is your speed? Your speed is, of course, 10 meters per second. So your speed is 10 meters per second. But however, what is your velocity? Your velocity is a time interval. Again, this is 20 seconds. But what is your displacement? Because your initial position and final position moving back and forth are the same. Your displacement is 0, so your velocity is 0. Okay. And then now you have finding speed of another example here, right? So you have a seabirds and then flying over the ocean, and then you can read this question. 60 mile east over Saarlouis at 3 p.m. and then 3:15, 80 mile. What is this? Velocity, right? So then it starts from here, ends here, right? So you're looking for velocity. So in order to find velocity, what do you need? You need a displacement, right? So displacement here is what? Final 80 minus initial 60. So it's a 20 mile, right? In other words, again, physical meaning of it is what? The object is moving to the right. So it's a plus. So your velocity is what? Displacement plus 20 mile. How long? For 15 minutes or 0.25 hours. Right? So the answer is 80 mile per hour. right? Another example, T12, Frank is x 25 meter, 5 seconds later, he's 20. What is his velocity, right? And then pause and complete your answers. Okay, so the answer, again, you're looking for the velocity, so you have to find the displacement. Final position is up minus 20 as 20, and the minus initial is up 25, so your displacement is up minus 5 meter. That means Frank is moving to the left, right? You can check it quickly, right? Why he was initially 25, and then finally 20, and then somewhere here you have origin, right? So Frank moves from here to here, so minus 5 meter left, right? And then you take initially start 12, and then 5 seconds later, so the time is 5, so your velocity is what? Minus 5 divided by 5. So the answer is minus 1 meter per second. And then let me talk more about the scalar and vectors in another section. And the scalar is quantity only, like temperature or speed. Whenever we talk about speed, I said we are interested in is a quantity only. But the vector has a both quantity and direction, right? So that's why speed is a scalar, because we are only interested in is a magnitude. But the vector, the speed, velocity, and displacement as well are vector. So that means whenever you say about velocity or displacement, you must describe both the quantity and direction. For example, in one-dimensional space, direction is either to the right or left only. So I said that's why whenever you say displacement, if you specify it's a sign plus or minus, it automatically indicates it's a direction. Same for the velocity. You always have to describe as a sign plus or minus. If a velocity is a plus, that means the object is moving to the right. If a velocity sign is a negative, that means the object is moving to the left. But whenever you talk about speed, we don't need the sign. So speed sign is always a plus. There's no minus sign for the speed. Right? Okay, and then I will talk next lecture. I will talk about trig, which is one of the most confusing part. So make sure you read, before the next section on Thursday. Make sure you read this part, okay? And then again, whenever you have a question, please send me an email. I can organize a Zoom meeting or I can answer your question via email. Okay. Have a nice day. Thank you for your time today. Bye-bye.